second to make sure I'm sharing the right things and minimize the right screens. But as Anita has said, I'm Sean Rafter, Head of Curriculum for Data and AI at Firebrand. And today we're going to take you through a kind of burgeoning area of artificial intelligence called generative AI. But before we get to the interesting parts around generative AI, we'll kind of we'll set the scene and we'll do some introductory stuff around what is AI, some of the machine learning concepts, and then we'll get into generative AI. So the first point of order for today is just to make sure that we're all in the same place. In terms of the definition of artificial intelligence. And whilst I don't like reading off a screen necessarily, when you're defining things, sometimes it's quite difficult. So AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. We can also apply that term to any machine that exhibits traits associated with the human mind, such as learning and problem solving. So clearly a really exciting area, an area that's seen huge volumes of growth over the last couple of years. Lots of organizations considering and challenging themselves in terms of how they're going to implement artificial intelligence and generative AI. But we really do need to kind of set our stall and make sure that we're having the right conversations, we're credible in those conversations, and hopefully this webinar will give you a really good understanding of what AI is, what generative AI is, and some of those relatively complex and unknown terms and frameworks and methodologies that are applied to artificial intelligence as well. So the first thing that we need to kind of cover off there are actually three main categories of AI. So within artificial intelligence, there's kind of three subcategories. And the first one is artificial narrow intelligence. We've got artificial general intelligence and we've got artificial super intelligence. And artificial narrow intelligence, that's defined as what is called weak AI. And weak AI is defined by its ability to complete a very specific task, like winning a chess game, or maybe identifying specific individuals of a series of photos. And we move into more stronger forms of AI, like artificial general intelligence and artificial super intelligence. That's where we'll see the incorporation of much more human-like behaviors, and they'll become much more prominent, such as the ability to interpret tone or emotion. Chatbots and virtual assistants that we're kind of all super familiar with, whether we like it or not, like Siri, obviously other versions are available. They are just scratching the surface of artificial intelligence, and they are actually examples of artificial narrow intelligence. So we can kind of call them weak AI. Strong AI is defined by its ability compared to humans. Artificial general intelligence, which is something that we are, as a society, aspiring to reach, that would perform on par with another human, whereas artificial superintelligence, also known as superintelligence, that would surpass any human's intelligence or ability. One of maybe a good thing, maybe not so good a thing, neither artificial general intelligence or artificial superintelligence, they don't actually exist yet. Lots of organizations are on the pathway to getting their artificial intelligence algorithms and models to a level of AGI, but we're certainly nowhere near artificial superintelligence. And actually, it's quite not necessarily a philosophical conundrum, but a lot of people say that if we ever were to invent artificial superintelligence, that would probably be the last thing that humans ever invent, because that artificial superintelligence would then invent everything thereon in. It would invent better things than humans could kind of invent. AI is maybe not as simple as you think. There are quite a lot of hierarchies within there. So we've got a couple of diagrams that I'll show here, and I'll just get my laser pen up. The diagram on the left defines artificial intelligence in terms of a bit of a hierarchy. And below that hierarchy, we've got machine learning. So you can think of machine learning as a subset of AI. There's complex statistical techniques, and they enable machines to learn over time through huge amounts of data quite often. And we call that data training data. Below machine learning, we've got another concept called deep learning. And again, that's a subset of machine learning, and it's comprised of algorithms that again train themselves to perform tasks like speech and image recognition, and they're using what are called multi-layered neural networks. And again, the more training data, the better. But when we're starting to think about artificial intelligence and trying to really define it and understand it, it helps if we can kind of start to bring some real life kind of examples. So the diagram on the right, and whilst the diagram on the right is maybe fit for purpose in terms of the present, these is certainly not an exhaustive or a definitive list, and the kind of components will change and increase over time. So one of the kind of main facets of artificial intelligence, and I think one of the key bits, is not all AI is machine learning. There are certain elements of artificial intelligence which don't include machine learning, but certainly I think it's fair to say the machine learning has been around for 50, 60, 70 years. So it's certainly not a new concept or necessarily new technology, but as data has become more structured and better recorded and compute power has increased, our ability to use machine learning models to make predictions has clearly increased over time. So one of the main components of artificial intelligence is called machine learning. And within machine learning, we've got kind of subsets. Deep learning, you might see deep learning used in terms of fraud identification. Maybe it's customer churn or customer retention, bearing in mind that it's 6 to 7 times more expensive to find a new customer than it is to retain an existing one. Predictive analytics is another aspect of machine learning. So trying to predict maybe whether if I'm a bank and I want to lend someone money for a mortgage, I want to predict whether they're going to be able to pay it off. Because clearly I don't want to lend money to people who haven't got the kind of capability to pay it off. And then within machine learning as well, we've also got clustering and classification. So it might be that I want to target marketing to certain demographics within my client base, and I could use clustering machine learning algorithms to automatically segment my client base into specific segments. So then I can target different interventions or different marketing strategies based on those segments. We've also got natural language processing as well, and that's where you might have seen some of this. Maybe if you're on with someone that's not a native English speaker within Teams, Teams will actually on the fly in real time translate, maybe not 100% as accurately, but it will translate from someone's native language into your native language, which is particularly important when we're communicating across kind of language barriers. Another really important part to natural language processing is sentiment analysis. So how can we en masse through huge amounts of unstructured data gauge the sentiment behind an interaction? So it could be that we've got lots of customer reviews in huge amounts of text format. We want to apply natural language processing to understand across maybe 500,000 reviews which ones are good, which ones are bad. And there's quite an involved process and lots of specificity around natural language processing as well. We've also got speech elements, so you could have speech to text, text to speech. These two elements have probably been around a little bit longer than some of the others in terms of us being able to access them. There are other elements which aren't necessarily associated to machine learning per se, such as expert systems, so knowledge systems, planning, scheduling, optimization, robotics as well. And if anyone's ever seen any of the Boston Dynamics robots, they are really very impressive bits of kit. And then we've also got kind of a vision branch as well, and that's where we'll have image recognition. So that could be the ability to identify a cat from a load of pictures of various animals. And we've got machine vision as well. And so we're seeing a lot of vision artificial intelligence and kind of models used within automatic self-driving. So Tesla's full self-drive, they've taken a slightly different approach to self-driving in the sense that there's no radar or LiDAR involved. It's all based off vision or all based off images. And so Tesla are building up huge amounts of training data, because even if you haven't purchased at quite a big cost the full self-drive for Tesla vehicles, all Tesla vehicles come installed with cameras, and whether you paid for the full self-drive or not, those cameras are going to be used to kind of build huge training sets of data. And that kind of segments really nicely into a couple of different subsets within machine learning. And one of the main subsets within machine learning, and there's actually three, is a concept called supervised learning. And the interesting thing between these three different kind of concepts is they generally can't be used for the same outcome or output They're used in quite specific circumstances. So there is supervised learning, unsupervised learning, and reinforcement learning. And so, for instance, you wouldn't be able to use unsupervised learning to identify images of cats from lots of images of animals. You need training data to be able to do that. So there's actually quite an interesting variance between the three different types of machine learning and where they can be applied as well. And they can be applied in quite different use cases. So we've got supervised learning here. And this little picture or diagram shows generally what we have with these types of machine learning models are lots and lots of raw data. Generally speaking as well, a lot of these models are statistically based, and generally speaking with statistics, the more data you can give the model, generally it can have a higher confidence level in terms of the outputs that it's giving you. So let's say, for instance, we want to identify a picture of a cat, and we've got tens of thousands, if not millions of pictures of animals. And we want a machine learning algorithm to identify which ones are cats and which ones aren't cats. And so all of the pictures would be depicted by this input raw data here. And we've got an algorithm that's actually going to process that information. But the key thing with supervised learning and the way that it is supervised is it's got human intervention. And what a human would be doing would be getting lots and lots of images of various animals, predominantly cats, and they'd be labeling those images. So the human is providing what's called a labeled training data set to the algorithm. So the algorithm's got lots and lots and as many examples as possible of what a cat looks like. And so when it receives lots and lots of images from its raw data, it's got a fighting chance of identifying a cat in amongst lots of other images of animals. Now, it's not necessarily ever going to be perfect at doing that. And there's lots of metrics which kind of gauge the performance of these algorithms. But generally speaking, the more information, the more data you can give it in terms of its training data set. So this is a picture of a cat and I'll label it as a cat. The more likely it is to be identify cats moving into the future. So once the algorithm has got a training data set, it can then move on to the processing part. It knows, generally speaking, and statistically as kind of high a likelihood as possible, what is and what isn't a cat. So at this processing stage, it will start to sort the output. Not a cat, a dog, a lion, however it wants to do its thing. But the main thing to remember for supervised machine learning is this human intervention, this training data set. I suppose the opposite of supervised learning is unsupervised learning. And you'll notice immediately there is no human here. There is no training data set either. So we get the same type of raw data, but we can't do the same thing for it. So we couldn't have an unsupervised learning algorithm that would identify cats for us. It doesn't work like that. The unsupervised learning has specific kind of outcomes. And it's really looking for hidden patterns within huge data sets, but it doesn't need that human. So unsupervised learning is often used, like I said at the beginning, for marketing in terms of customer segmentation. So in the customer segmentation example, this raw data would be your client base. And the algorithm and an interpretation mechanism would look at the data behind the client base, so who the client is, what size of company they are, whereabouts are they within the geography of the world or the UK, what do they sell, and it would start to segment those customers into specific segments, and it would do that automatically. It wouldn't necessarily need a human to say this client sits in this segment. It would automatically do that. So in the example of customer segmentation, we've got a load of client-based data here. The algorithm will interpret that data, it will process it, and then it will develop segments. So it will put clients into specific segments in this example. Then once we've got those segmented clients, we can start to diversify marketing strategies, and we might do some more deeper dive analytics in terms of what are the elements that make this segment, what are the interesting facets to it, and that might then generate marketing approaches and differentiation in terms of marketing strategies. The third aspect of machine learning, and probably a more modern aspect of machine learning, is what's called reinforcement learning. And so again, there is no human intervention. There's no human data set here, but we've still got that raw data that we kind of feed into the algorithm at the beginning. And what the algorithm is doing is it's trying to maximize a reward. And clearly humans will have a part to play here in terms of defining what the reward looks like. and what the actual algorithm needs to maximize. So the algorithm is given a load of information. It defines the state. It will then select the algorithm. It will take the best course of action to maximize the reward. And it's an iterative process between the agent and the environment. The agent is getting fed data. It's taking a course of action. It's assessing whether that course of action gets a reward, and it's trying to maximize the amount of time and the amount of rewards that it gets. It's a little bit like teaching a dog to sit. If you just say to a dog, sit, it's probably going to look at you blankly and do completely the opposite. If you tell a dog to sit and give it a little treat, over time, that dog's going to learn, if I sit, I'll get a treat. So the dog is trying to maximize its rewards. And if you own a dog, you'll know that it rarely ever does anything else other than to kind of maximize its rewards as well. And we see reinforcement learning used a lot in video games because actually it can create quite lifelike artificial intelligence. And one of the things of video games is the more enjoyment and the closer to real life often a video game is, generally it becomes more popular. There's quite a famous example, and depending whether I'm speaking to a load of World of Warcraft players, which I may be, I might not be, there is a mod of Warcraft called Dota. And what some individuals did is they applied reinforcement learning to this game called Dota, and they were able to play the game for 45,000 years. And that's because they were able to speed up the game, and they were also able to play it in parallel. And then that actual algorithm that could defeat human professional players as well. So they actually ended up playing 675 million games of Dota using this reinforcement algorithm to be able to train the algorithm to then go and beat human competitors as well. So you'll tend to see a lot of this algorithm used within recommendation engines for Netflix. So Netflix is an organization that's built on data, that is using as much data as it can to try and give you the best selection of content possible. And reinforcement learning plays a part in terms of building up that concept as well. This diagram kind of defines a little bit more specifically where you can get some of the use cases for these different flavors of machine learning. So I won't necessarily for time take you through all of them. But for supervised learning, we've got regression. And regression is used, for instance, a lot in weather forecasting. And regression is the idea that we might have relationships between some data variables that we're measuring. Classification is probably one that, whilst we might not have been super overtly aware that it's being applied to us, if we've ever applied for a credit card or a loan or a mortgage, the banks and the building societies and other financial lenders have got a binary decision to make. They either lend us money or they don't lend us money. There's two kind of outcomes, and very rarely do you get into a conversation that's a kind of hybridized approach to that as well. And the same thing for image classification. It's a binary outcome. This is either a cat or it's not a cat. And so whilst I don't think many of us will necessarily have had image recognition applied to us, and hopefully not, we will probably have been through the situation of trying to lend money from an organization at some stage. And it isn't necessarily all about money. There's identity fraud detection as well. So have you been a victim of fraud or haven't you been a victim of fraud? Is this email spam or is it not spam? So these kind of classification algorithms, we've actually probably been using them or been exposed to them for a good number of years now. We've got unsupervised learning, and there's kind of two main aspects to that. And we went through in a little bit of detail the clustering element to it. So you can see the targeted marketing and the customer segmentation piece there. The other interesting aspect of unsupervised learning is dimensionality reduction. And there are some quite maybe unknown terms here, such as feature elicitation. And really what feature elicitation is feature is a variable within a data set. So it could be the average spend of a customer, if we're in that type of domain. And feature elicitation is trying to find the best data to then power the model. But sometimes some people explain dimensionality reduction a little bit like Google Maps. So when you're in Google Maps and you're zoomed out to kind of a level where you can see the entirety of the UK, you can't see B roads or shops or A roads. You can generally just see motorways. And as you zoom in, you can see more and more detail. So dimensionality reduction, if you're taking that Google Maps analogy, is like being zoomed in on Google Maps. And as you zoom out, the dimensions that you can see, the B roads, the shops, all manner of other things that you see on Google Maps. As you zoom out, you get less of those. So the dimensions are reducing over time, and as you're zooming out. So generative AI, really, that's just AI, but it's generating content. It could be images, it could be text, it could be video. And we've all been exposed to, and I know that ChatGPT is not the only large language model out there. But when we think about the likes of Copilot or Claude AI or ChatGPT, that is generative AI. They're generating content for us. And actually ChatGPT, the GPT bit stands for Generative Pre-trained Transformer. So the actual model has been pre-trained with data. So when you're interacting with ChatGPT, it's not actively training itself. It's already been trained on the likes of Wikipedia and Reddit, etc., etc., etc. One of the interesting aspects of actually how ChatGPT works is the concept of autoregressive models. And also regressive models, they generate sequences one stage at a time. And they are used to predict the next element in a sequence of tokens. And if we think about text generation specifically, and I think we probably had experience to text generation within the likes of ChatGPT, it means predicting the next word given the previous words that have occurred. And the autoregressive nature requires the maintenance of a rich representation, not just the next element to predict, but the entire context that's relevant for making the prediction. So you could get a large language model that would predict the next word based on the word before. But what autoregressive models aim to do is take a much wider view in terms of prediction. And this is where the concept of self-attention starts to come in. And there is a lot of new terminology around Gen AI. And when you break down self-attention, effectively it's weighting. So if you take, for instance, a sentence of maybe 10 words, what autoregressive models want to do is look at all 10 of those words to predict the 11th. But self-attention is the concept of not all of those 10 words that precede the 11th are as important as each other. So they're weighted, and when they're weighted, the model knows to take more cognizance of the higher weighted elements or words than some of the lower weighted words. So for instance, we call them in data science and big data stop words, words that don't have any semantic meaning. So then and the and they, etc., etc. Those types of words can clearly be within text inputs and outputs, but generally they don't have a huge amount of semantic understanding. And specifically when we're predicting the next word, self-attention allows the model to look at the entire sentence or document that's been generated so far and make a really good guess at determining which words are most relevant to inform the next word in the prediction. And for anyone that's used the likes of ChatGPT or Copilot or Claude AI, it's actually really, really good at doing that. And that's why there's been such a big kind of voluminous increase in the interest around this type of technology, because from a text basis, it actually looks like we're interacting with something close to a real human. And whilst we're not, we're just interacting with an algorithm that's really smart and based on statistics. You can see the kind of difference between something that's quite statistical, and it's a very gray line in terms of when it starts to become something that looks and feels like a human. Another really important aspect of generative AI is a concept called generative adversarial networks. And they're a type of generative AI model that consists of two neural networks, a generator and a discriminator. And what happens is the generator generates from random noise. In the example of images, it would produce fake images. And what the discriminator would do is it would have access to a huge volume of real images. And what the discriminator tries to do is work out whether the generator has created a fake image or whether it's a real image. And you can see the outcome of this little diagram here is the predicted labels. Is the image that the generator has created real or fake? And so they're adversarial. The two networks are trained together in competition until the generator network produces an output that can fool the discriminator network. And we get a lot of the use of GANs within image, video, and music generation as well. And the potential of GANs in the creative content generation is potentially enormous. And it's been increasingly used in lots and lots of different domains. And you can see the kind of the increasing capability of the likes of ChatGPT is increasing over time, and its ability to generate images is starting to become a real thing now. It's actually able to create realistic looking video as well. If anyone's seen the first stages of trying to get AI generated content in terms of video, you might have seen a video of Will Smith eating noodles, and you could very, very easily spot that that was a fake video. But over time, it's going to be virtually impossible, even for humans, to decide what's a real image and what's a fake image. And clearly that has large amounts of implication for regulation, for copyright, etc., etc., etc. And these are the things that our governments and regulatory agencies are considering as we speak. Another really important facet, and something, again, if you've used ChatGPT, you're becoming more and more familiar with, is the concept of prompt engineering. And so AI prompt engineering, specifically, it's the practice of crafting inputs for artificial intelligence models, particularly generative models, to elicit specific and high quality outputs. And it often involves writing and refining and optimizing prompts to guide the AI's responses. And if you've ever generated and used prompt engineering, clearly models like ChatGPT use natural language understanding, so you can communicate with it in natural language, but then there are limitations in terms of its ability to understand. And so sometimes you'll need to adjust the prompt or give the model a little bit of extra information. And you can achieve a lot with simple prompts, but generally the quality of the results depends on how much information you're going to provide to it and how well crafted that prompt is. A prompt could contain information like an instruction or a question that you're passing to the model. And it can include other details like context or inputs or examples. And you can use these elements to improve and instruct the model effectively to increase the quality of results. And within prompt and engineering now, and this is a relatively new thing, they're starting to categorize the different types of prompts that you can give your models. And the reality is, if you have played with ChatGPT, and obviously other large language models are available, you've probably subconsciously, without necessarily categorizing it, done quite a few of these different types of prompts. But I think it's really powerful when we start to understand exactly how we're prompting these large language models, and then we can much more easily kind of control that and evolve that over time. So the first kind of prompt engineering technique, and again, not a definitive or necessarily exhaustive list, but the main types of prompt categories that we're using. The first one is called zero-shot prompting, and it's a technique that allows a large language model to generate outputs for tasks or domains that it's not been explicitly trained on. And again, using natural language instructions. So you might want the model to write a poem about love, or you might want the model to write a bedtime story for your son or your daughter. And you can provide a simple prompt like write a poem for love, and the model will try and generate a poem that matches the request. Few shot prompting is very similar, but that's when you're going to give the model a little bit of a clue. So say you want the model to classify 4 pieces of text into 4 different categories. You would actually give the model examples about an example piece of text and an example categorization that model will have. So you're giving the model a little bit of information, and the model will try and infer the task in the categories from the examples that you've given them, and it will generate an output that matches the format and the styles of the prompt that you've given as well. So zero shot, you're not giving the model any clue whatsoever. Few shot, you're giving the model some suggestions. I want you to do this, and here's an example of what I want you to do. And then we've got chain of thought prompting. And that's a technique that's used a lot in the likes of ChatGPT, Claude AI, Copilot. And that's where it's going to generate more detailed step-by-step explanations for complex queries or problems. And the idea is to prompt the model not just to provide the final answer, but also to get the model to show its chain of thought. How have you got to that output? What are the reasoning steps that you've kind of taken through that's come to that answer? Understanding how the model has got to that kind of prompt or the output that it's given you can help you validate the output, can help you evolve that prompt as well to get a higher quality output if that's the thing that you want. And the final one that I'll take you through in terms of prompt engineering is the idea of chain of feedback. And chain of feedback is similar to chain of thought, but the key difference is that on a prompt after prompt basis, so as I'm asking the model for its reasoning, I'm going to provide feedback to the model about how things are coming along. And the idea is that we're able to give explicit intermittent guidance to steer the model in a direction that will hopefully end up producing the best probable answer. And I think if you've used these large language models extensively, you've probably, and I certainly have naturally started here, moved on to few shot. I maybe have skipped chain of thought, and actually chain of thought is maybe a more nuanced aspect, but I've gone quite easily into chain of feedback. So I'm iterating, and the prompt generation and engineering is an iterative process. And the other cool thing with chain of feedback is that it is showing promise in minimizing hallucinations from LLMs. And if you take anything away from kind of generative AI from today's session, if you take nothing else away, validation, 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 validation. Just because a model gives you an output doesn't necessarily mean it's right. And actually, one of the key aspects of using these large language models effectively is the ability to be able to then validate or get the model to validate. So, for instance, when ChatGPT first came out, I asked it for the top 10 books in data analytics and the links to the Amazon store where I could go and buy them. Clearly, other book retailers are available. And it gave me those top 10 books within seconds. And it looked amazing. There was the book, a little explanation of what the book was, and then the actual Amazon link. It turned out none of those books existed. None of those authors existed. None of that content existed. But the large language model was certainly not proactive in telling me that none of this stuff existed. I had to validate it myself. And it is one of the most important aspects of the use of any of these large language models is validation. And also the fact that these models are constantly improving. They're constantly being given training data and additional training data. And that's one of the slightly controversial aspects to it. Quite a lot of the prompts that you're giving the likes of ChatGPT are being used to train that model. And we do need to be super, super aware of that as well. And you know what? It isn't all I don't think necessarily AI is going to change everyone's life. It is good in some regards. It's not so great in other regards. So what I'm going to go through a couple of tests that I did in terms of image generation. And this image generation software is called Bing Image Creator. And if you do sign up for Copilot, you'll get access to Bing Image Creator. And clearly there is a Copilot, a personal one, and there's a Copilot kind of on an enterprise kind of fashion. But I just wanted to test what can these image generation tools actually do. So the first test that I did is I wanted the algorithm to basically do my work for me and generate an updated version of this little diagram that I've already taken you through here. And so you'll see when I get to the right slide, where am I? Oh, this is not cool. Here we go. You'll see when I actually gave the prompt. So the prompt I gave, you can actually see here, diagram showing supervised, unsupervised, and reinforcement learning and its use cases. So a relatively bland, not a particularly descriptive prompt by the same token. And this is what it produced. So it got absolutely nowhere near where I needed it to get to, and I would need to do a lot more chain of feedback prompting to get to the stage where it could generate and replicate actually what I wanted it to do. And I might be in the space of it may well be quicker to do it myself, but we haven't necessarily got to that place here. But you can see some of the things that these image generation algorithms struggle with, particularly around language. Even though I've given it the term supervised, unsupervised, and reinforcement learning, it's come up almost with an entirely different language itself. So while it's nailed the word learning, it hasn't really nailed the word in reinforcement, hasn't really nailed the word supervised, and I don't even know what that word it's attempting to spell out is. So there are limitations with these large language models and with generative AI. But you know what? There is with every new type of technology. And over time, it will improve and it will increase. And you know what? One of the main ways it will improve is with humans giving it information, actually feeding back. Well, this isn't that great. This is what I would have expected to see. I'm a big Liverpool fan. And when I was creating this webinar, and developing the slides, this is maybe a little bit more pertinent than it kind of is today. And I was a little bit hopeful and asking it to give me a picture of Liverpool winning the Premier League title just to see what it would do. And you know what? It's got a pretty decent representation of the actual trophy. You could probably not Anfield, but it looks like we've made some significant new signings. Whoever Lodge Pron is, he's going to be the number 9 striker for Liverpool moving forward. So again, a relatively decent image, but really struggles with text for some reason at this stage. And I certainly think that will improve over time. Where it does excel, though, is if you wanted a watercolor picture of a cute cat eating ice cream. So absolutely nailed that. Absolutely nailed the image for that. But there is no text in there either, so not necessarily super surprising. But there potentially, in terms of the world of work, I don't know how often I'm going to get paid to get AI to generate a cute cat eating an ice cream in a watercolor fashion. But what I probably will get paid for is developing learning outcomes for complex ideas around artificial intelligence and machine learning. And this is where the likes of Copilot in this example, or ChatGPT, or Claude AI, and there are others available, really, really do excel. So when it's a text-based output, when I'm looking for something really, really specific, yes, I still need to validate it, but it becomes incredibly powerful when we're using natural language. So if I want to develop some text, regardless of whether the concept of text I want to work out is complicated or not complicated, actually these large language models start to provide a massive benefit in terms of their output. So I kind of see in this regard, this type of functionality, it's like using Google search, but it's combining 10 hours worth of research into kind of 30 seconds in terms of the output, and then maybe another couple of hours worth of validation to see actually whether the output is legitimate or not. There's lots and lots and lots of new terminology around generative AI. And I suppose this is not, again, not an extensive or an exhaustive or a definitive list of some of the terms that you're going to face, but actually there's some interesting kind of concepts and interesting pieces of terminology around this. And the glossary around AI will increase exponentially over time. There is absolutely no doubt. But some of the foundational and fundamental common terms around large language models, and if you want to get into the realm of AI, clearly credible technical conversations are a really important kind of facet. Understanding this terminology and some of the context around what it means is also super important as well. So the first one is a foundational model, and you may not have heard that term, and that's a large language model to generate and understand human text across a wide range of cases. So maybe those first iterations of ChatGPT where you could kind of coin as a foundational model. A transformer, another really key facet of these large language models, that's a component known for its attention mechanism and parallel processing capability. An attention mechanism, that's really the weighting. So these large language models have got huge amounts and huge volumes of data that's going in to train them, but actually not all that data is equally important. And transformers are the idea that we can actually start to weight more important information, and the model can actually focus on processing and using some of the higher weighted variables rather than some of the lower weighted variables. We've kind of already covered across prompting as it stands, so that's giving those carefully curated inputs to large language models to generate those desired outputs. Context length is really important as well. And there's a couple of kind of subterms within that, depending on the kind of subscription you have to these large language models. It might limit the number of words you can give in terms of a prompt. So you might be limited to 2,000 or 3,000 words maximum, and that might feel like a lot. But if you're really stretching the capabilities of these large language models, that word count actually isn't enough. And there's tokens as well. And tokens, in some sense, you can think of that of the ability for the model for you personally to learn about you. So if you've ever used ChatGPT and you've got yourself in the situation you're constantly asking it to give its prompts in UK English, you might have realized that it will forget over about 4 or 5 prompts. And that's because it's working on a token basis. And so if you've got the free version of ChatGPT, you might only have access to 5 tokens. And really, and I suppose specifically, that is the model can remember 5 prompts or 5 inputs before. So if you've told it in prompt 1, I just want UK English, and then you get to output number 6, it will have then probably converted back to US English. It is not the large language model trying to destroy the English language. It's just managing its compute power is probably a fair way to put it. The concept of RAG, and RAG in I suppose old money is red, amber, green, and in new AI money, RAG stands for retrieval augmented generation. And that is the ability for the large language model to give you an output. So you might have asked it to research, I don't know, something to do with black holes and astrophysics. What the large language model will have done is will have gone and gathered lots and lots of information, which is actually called a knowledge base. But the RAG process is just picking out those key bits to develop the output it's going to give you. So if you're asking a large language model a question, it might have researched 50,000 words or 50,000 documents, and the RAG process is just boiling down the salient points of all of those words and all of those documents. So the knowledge base is everything that a large language model collects in terms to give you an output, and the RAG is the process to really generate that specific output that it's giving you. A vector database, that's quite important when we get into natural language processing. That's storing data in a vector. And a vector is a very specific data structure. If you've used Python or R, you've probably come across this concept of a vector. And effectively what a large language model is doing. So if you take, for instance, sentiment analysis, where you might have reviews of your product, what the model is doing is it's isolating each one of those words into a specific structure called a vector. There are other processes that natural language processing algorithm will go through. For instance, stop words, removing those stop words, so words that have no semantic understanding. But actually, the way that data is stored, predominantly for text, is in what's called a vector, and that has led to the rise of these vector databases. And then we've got the concept of fine-tuning, and then that's adapting a large language model to a specific task or domain using further training data. So one of the big kind of missing pieces from the likes of Copilot or Claude AI is the fact that it's got a lot of, and maybe Copilot isn't the best example of this, but if you take ChatGPT and Claude AI, yes, they've had lots and lots of training data, but what they haven't had is the Firebrand internal data or the internal data from a major insurance provider in the UK or a major bank. It's been given open source information. It hasn't got private information. And actually, when we start to add those two things together, we get an even more powerful large language model when we start getting into the space where maybe we're in a domain specific large language model. But hold that thought there, because I've got a slide that will take you through that in a little second. And then we got that concept of hallucination. So there is the tendency of large language models to generate incorrect information, which is why I said validation about 17 times in a row, because we need to know with confidence when our model is hallucinating or not hallucinating. We might make business decisions based off the output of a large language model, such as giving a load of learners access to 10 books around data, which all transpired to be false. I totally didn't do that because I validated the output before it got to that kind of stage. So again, not an exhaustive or a definitive list, and you'll start to see these types of glossaries building over time as more and more of this type of language becomes more familiar to us, and we need that short, sharp explanation around it. There's a lot of ethical conundrums and moral conundrums about the use of artificial intelligence as well. And ethical and responsible AI are two terms that are starting to come more to the fore. And there is a difference between the two terms. They are not the same thing. And I suppose the simplest way to think of them is ethical AI is considering those kind of moral conundrums. Should we do that? Whereas responsible AI is the kind of governance and management of AI within an organization or outside of an organization. But ethics in AI is crucial because we need to develop AI systems that are used in a way that respects human rights and values and prevents harm as well. They also should promote accountability and transparency, because that's vital for building public trust, and it facilitates that responsible innovation in AI technologies. And bias is a really important facet. Generally, these AI algorithms, these machine learning models, they're mathematically based and statistically based. It's really difficult for maths to have a bias, particularly if it's been done correctly. And where our bias tends to come from in terms of these large language models or any other AI systems is from the training data that we give it. So AI systems can inherit or even amplify human biases such as gender, race, and class because they're present in some of the training data. And it can lead to unfair or maybe even discriminatory outcomes, such as hiring decisions, maybe credit scoring. Facial recognition is quite a controversial use of artificial intelligence as well. And a study recently found that AI systems used by US courts to predict the likelihood of recidivism, so repeat offending within crime, was biased against Black defendants. And clearly, we need to identify and have frameworks to understand: is our outputs biased? Where is that bias coming from, and how can we mitigate that bias moving forward? But maybe accepting that it might be impossible to mitigate bias completely. It probably is impossible to mitigate bias completely. And we need that accountability piece as well. We need to be able to, we want those AI models to make decisions and take actions, but we don't want them to adversely impact human lives. There's the rise of autonomous vehicles. We've got AI algorithms being used in medical diagnosis, or maybe they're part of military drones. Although it's not always clear who's responsible or liable for the consequences of these decisions or actions, particularly when AI systems are really complex. They may be opaque, they may be semi-autonomous or autonomous. So, for example, who should be blamed if a self-driving car causes an accident? Who's responsible for that? And I know a lot of insurance companies are actively considering this conundrum. Who is responsible for an autonomous vehicle when it crashes? Transparency is super important as well, and probably for me one of the trickiest bits of this kind of rise of artificial intelligence. It is when you start to get under the hood of these AI models, it is incredibly complex, incredibly mathematical, incredibly statistically based as well, which gives us an issue in terms of our ability to explain it, because these AI systems are collecting, processing, and analyzing huge amounts of maybe personal or sensitive data. And actually, how can we verify and validate and audit the behavior or the performance or the reliability of these systems? And unless we fundamentally understand how it's doing, it's very, very difficult for humans to manage it. How can we trust an AI system that diagnoses a disease or recommends a treatment without knowing how it arrived at that conclusion? And that's going to be a huge challenge for a lot of organizations, and probably a huge area of growth in terms of jobs, being able to understand these models to an extent where we can start to explain some of the actions that they're taking. Privacy is obviously a super important thing as well. A lot of these models are collecting and processing personal sensitive information. It could be biometrics or health, or maybe even financial data. And obviously it raises the issues of data protection, consent, ownership, security. So how can we ensure that our data is not misused or leaked or hacked by other AI systems or their operators? And whether we know it or like it, a lot of the prompts that we're giving to ChatGPT and Claude AI and different large language models are being used in training data. So what we certainly don't want to do is give it any of our own organization's intellectual property. One of the really good uses of these large language models is debugging software code. But do we want to be giving? Do we want to effectively write all of our software code on a poster and stick it on a town hall? That's generally not going to promote our own intellectual property. And so we need to be really careful in terms of how we're using it. And actually, Copilot from Microsoft has two different versions for their large language model. They've got a web version where everything that you prompt will be used in a training data set, and they've got a work version where everything you prompt will just be kept internally. So there are ways to overcome some of these privacy issues. And the final bit is around AI ethics. And how can AI systems, how can they have moral or social implications, or what moral or social implications should they have? Will they have the ability to impact on human dignity, autonomy, rights, values, or norms? How can we ensure that AI systems respect human rights, such as freedom of expression, or privacy, or non-discrimination? How can we assure that AI systems align with human values such as fairness or justice or empathy? And this may well give rise to new roles such as AI ethicists, individuals from a really broad background that are considering all these conundrums and helping organizations make a judgment in terms of their use of kind of AI moving forward. The future outlook, the relatively short distance future outlook in terms of some of these generative AI models, is photorealistic imagery and video. Might be moderation improvements as well, so it's able to moderate its outputs. In the medium term, we're going to get better knowledge representation, hopefully increased explainability as well. Over the slightly longer term, so maybe 5 years into the future, we're looking at I could even say it, multimodal reasoning. Multimodal within artificial intelligence and machine learning is the ability to start joining together different facets. So we saw the ability to classify images. If we've got a load of images of individuals or animals, can we identify which ones are cats, which ones are dogs? But then multimodal is the combination of different types. We might want to combine that with some natural language processing capability. So it's starting to join up these not necessarily disparate, but isolated facets of machine learning and artificial intelligence. We're starting to join them together. And for me, when we start joining them together, we're going to go much, much closer to artificial general intelligence, that intelligence that is on par with human intelligence as well. And that could have huge implications of business strategy and planning as well, where maybe we're in a strategizing phase within our business, and we might want to see what the AI model thinks about what our strategy is, or maybe it can recommend some considerations around our strategy as well. One of the most exciting bits for me in terms of these large language models is the rise of domain-specific large language models, recognizing that the likes of ChatGPT, they have made significant strides, but there is an increasing interest in tailored specific models. And they're designed to cater to niche areas that will have specialized knowledge and vocabulary. So we could have a bio-GPT, a large language model specifically for the biotech industry or biomedical research, a thin GPT, that could be for financial forecasting. And this will allow us to reshape industries by offering more accurate, efficient, and relevant insights. And these large language models will they'll require specialized training data. So if you want a specialized bio-GPT, you're going to have to give it a wealth of biomedical information to be able to train it on. So they'll need to be focused in particular industries or fields or topics. It could be healthcare, finance, scientific literature. And that contrasts quite heavily with the way that we're using these large language models now, which are trained on much more broad and diverse data sets. And I think when we add in the broad training with the industry specific training, we're going to get incredibly powerful and valuable large language models as well. We'll probably need some customized architecture as well. We might need to more frequently modify or fine tune our large language models to better suit our needs and characteristics of the domain that we're working in. It might be we need to include specialized vocabulary or entities or reasoning patterns. The way that we think in a specific industry might differ industry to industry. They'll need to have improved domain understanding. So they'll need to develop a deep and contextual understanding of the terminology and concepts and relationships that are prevalent within the target domain. And again, that will enable more relevant and more accurate outputs. We'll also need to have enhanced task performance, and due to these domain-specific knowledge requirements and capabilities, these models will typically outperform any general-purpose large language models on tasks that relate directly to their target domain. So if we're working in a medical area, we want to make clinical decisions, we're not going to use the likes of ChatGPT. We're going to want to use this domain-specific large language models. And these are tailored applications as well. And these domain-specific large language models are often developed and deployed to power AI-powered applications and services, which are specifically designed for that domain. Beyond the future, where might we get to kind of beyond 5 years? Well, and this is clearly an inference. This isn't necessarily fact. So the things I'm going to take you through quickly here. We're not guaranteed to see these. We're being futurologists. We're guessing from what we can see in terms of the use of large language models, their trajectory, what kind of implications there might be across a broad spectrum of areas. So we might have the transformation of the scientific method, because AI and machine learning will enable computers to learn from data and discover patterns and relationships that whilst humans can, they probably can do it on a much higher volume with much larger data sets. So they'll be able to help scientists analyze large amounts of data. And this type of stuff's being done already. If you've ever looked at any of the CERN papers that are coming out, AI and machine learning are helping scientists understand these interactions with particles, because the volumes of data and the concepts behind them are so very large and very concepts and very difficult to understand and complex. AI may well be able to generate hypotheses. It might be able to design experiments to test those hypotheses and then verify the results of those experiments as well. So it could enable new forms of scientific discovery, which could be really cool for society across the globe as well. Potential for AI to become a pillar of foreign policy. And you probably didn't expect to hear that coming onto a Firebrand webinar, but these models are so very powerful and very valuable that at a certain stage, nations will use them as leverage. Come and be friends with us, because you can have access to this, and you'll also get access to our AI model as well. So you might start to see these models, certainly from a country basis, starting to not interfere, but implicate themselves in terms of foreign policy. They could be used as a lever. Probably one of the more interesting bits is maybe the ability to enhance interaction between human and computers. When we get to more multimodal communication, so when these AI algorithms can not only listen to what we say, but they can see how we're gesturing. They can maybe look at our kind of non-verbal communication cues as well, and generate a much more rounded response rather than just interacting with us through text or through speech. Maybe one of the most important facets for the kind of development of humans over time is this ability to democratize access to knowledge and education as well, because AI will be able to provide access to knowledge and education for anyone, anywhere, and at any time. Provided that we regulate the use and the development of AI and don't make it a class system in terms of the more powerful AI algorithms are only available to the people with the most amount of money. That isn't necessarily going to help knowledge and education. I think it's something that all governments should be focused on in terms of that equitable access to AI algorithms. But if you can learn anything, anywhere, and at any time, that is going to help the increase of human knowledge over time. And it could get further than that. And AI could help create personalized and adaptive learning systems. It could help teachers. Imagine if you had an AI algorithm that was in a classroom and it was monitoring every single learner in that classroom, and it was feeding back to the trainer. Learner number one, their non-verbal communication cues suggested they didn't understand how you explained this concept. You might want to diversify the explanation. And actually, I know how you explained it, the AI algorithm will say, and here's a diversified approach to explaining that algorithm. That could be very cool in terms of learning as well. And it might well, and hopefully will empower social good and impact. Because AI might be able to help alleviate some of our most pressing social and environmental challenges. It could be poverty, health, climate change, human rights, because AI can monitor, measure, and understand problems and then present insights and solutions to those problems as well. So we could start to see, and hopefully we'll start to see, AI changing the climate for the better as well. Couple more slides before I let you go. Probably more administrative, but it's clearly Firebrand are a training organization. And whilst we'd love to deliver these webinars and spread some of our knowledge for as far as we can, we are a training organization and we will offer a lot of training courses. So if this AI webinar has whetted your appetite for this kind of burgeoning area, lots and lots of courses that Firebrand offer. So we've got a slide up here, and I'm sure Anita will stick in the link into the chat in terms of where you can get access to them. And we've also broken them down in terms of their kind of knowledge levels. So the green ones are foundational, the orange ones are intermediate, and the red ones are advanced. The certain Nexus ones are really, really good to get you a general understanding. And they're kind of, some of them are more focused towards management levels. So managers clearly need to empower their staff to be able to use AI, but if they're unable to communicate and use the right terminology, they're going to find that really challenging. So some of those courses, particularly the Gen AI Biz, are developed to specifically upskill managers so they can get more comfortable with the vernacular. We've got elements around prompt engineering. If we want to get really under the hood in terms of AI, we've got the ability to develop Azure models within Azure, and an associate course there from Microsoft. A more fundamental course, AI Fundamentals, actually a really, really course. I'd encourage anyone to go onto that. The specific elements around OpenAI and ChatGPT as well. So maybe you're looking to implement within your organization. Understanding how to embed it and develop it is definitely no bad thing. Really good courses from an ISO point of view as well, in terms of a foundation understanding, implementation and audit aspect. The British Computer Society have got some really good courses around AI as well. And one of our big partner vendors, in fact, all of these are vendors of Firebrands and partners of Firebrands, by Saka as well, have got really good courses, particularly that certified in emerging technology course. One final thing before I show you a picture of Rembrandt asking questions is, you might be a small and medium enterprise, and you might be thinking about, well, those Firebrand courses might be expensive. They are very competitively priced and very, very good value for money. But maybe you're a small, medium organization. So that'd be an organization between 1 and 250, 249 employees in the UK. The government have come up with a flexible AI upskilling fund pot. So just under £6.5 million of funding for this calendar year, 24 to 25. It is only for UK-based small medium enterprises. The government will take some of that £6.5 million and 50% fund some of those AI skill training courses as well. In order to access that funding, you need to submit an expression of interest by the 23rd of April, which is not too many days away. The applications process for grants is open to the 1st of May. And I know this will come as a shock, Firebrand are an approved training provider on that as well. So there's a website there, or a link there, that I'm sure Anita will stick in the chat as well, and that'll take you to a government page, which will kind of take you through all the facets, but it's for training skills only. So it can't be used for training or purchasing AI technologies. It's not for consulting. It isn't for recruitment. It isn't to pay for salaries, and it isn't for capital expenditure. And as with a lot of government funding, they come with a lot of rules to follow. And to be eligible, you have to be registered and operate in the UK. You've got to employ between 1 and 249 employees. You've got to be defined as an SME as per the SME action plan. I'm sure if you're an SME, that'll be much more familiar to you than it is to me. You'll need to have been operating for at least a year, and you'll have to be able to match the other 50% of that funding piece. And it's the idea is to increase AI adoption and productivity by incentivizing greater employment-led investment in training and skills with AI. And that has been me. I shall leave you with the most impressive image that I've ever generated from AI. And this is prompting AI to give me a picture of questions and answers, and a questions and answers picture in the style of Rembrandt. So you might not have thought that was possible, but it appears to be possible. I hope you found that interesting. I shall now stop sharing and see if there's any questions. Hopefully, 4 minutes over as well, which is not too bad for me.
I was thinking the same, Sean. Thanks ever so much for that. There was a couple of questions for those that are still stayed online. This has been recorded, and we will be uploading it into the Firebrand YouTube channel. So if you've enjoyed it and you want to go back and revisit some of the content, you'll be able to do so. One of the questions, Sean, was, how do you validate the information generated by AI?
Through lots and lots of internet searches, effectively. I mean, how would you, it doesn't differ from how you would validate anything else. If you've asked a member of staff for a response to something, how would you validate their response? It'd be partly through your domain knowledge, partly through your own knowledge and partly through a little bit of research. And it's actually no different from generative AI. Just because someone says something to you doesn't necessarily make it true. You've got to go through all of your own individual reasoning processes to work out whether you think it is or it's not true. So it's actually no different from the validation of any other information, domain knowledge and research.
Brilliant. And what do you think the main AI risks are now and in the future?
Training data, training data, training data, training data. I mentioned earlier that the more data you can give these AI algorithms, the more confident they can be in their outputs. And generally speaking, could you get a human to review 500 million records to see whether there's any bias in there? That is going to be a very, very tricky thing to do. I would imagine there will be software provisions that will help you do that. And I don't think you're ever going to mitigate all bias from all of your training data. So it's a bit of a juxtaposition. I want the model to be better and to give me better outputs, give it more data, but I've got the risk of carrying bias within that data. There's Princeton are actually doing some really good case studies in terms of those kind of ethical conundrums and those bias issues as well. So get yourself onto the Princeton website. They've got a specific AI section. They're coming up with case studies, particularly around AI bias, how you identify it and how you go on to mitigate it as well.
And a last minute question there. Do you recommend creating a validation loop? And if so, what would be an effective way of doing so?
I think it would probably, what you probably need to have in place before you did that is an AI strategy. You probably need to have a data strategy in behind that as well. So I wouldn't advise many organizations to just create a data strategy. You'd need to have that in synergy with an AI strategy, and then it becomes a governance process. If you're looking for that bias, if you're looking to mitigate it, the first solution is to be able to identify it. So a governance process should help you identify some of those outcomes that you don't want, and then you need to feed that into a bit of a loop around a potential governance process. Some organizations are on the verge of setting up, or they are setting up, what are called AI councils. And generally speaking, in the world of AI and ethical the use of AI, the broader demographic you can get to make up those AI councils, generally the better the outcomes you can get in terms of identifying some of the less cool outputs and then putting mitigations in. But you need to accept that sometimes, based on the outputs and based on the data you've given it, you might not be able to mitigate all that bias. So then you're into a policy situation of, when we're unable to mitigate bias, how do we organizationally overcome that? How do we learn from that? How do we plug it into our organizational memory? And how do we mitigate maybe some of those less favorable outcomes? So a good example is, if you're going to use AI to analyze X-rays, you might want to fine tune it so it suggests that more people have got broken bones than less, because what you don't want to do is send someone home that's got a broken leg without a plaster cast or whatever the newfangled way of setting a bone is. So you can start to fine tune those models as well to become slightly less risky and a bit more risk averse. Never a short answer from me.
There never is, but for most things. We did have a hand up, but I think the hand's gone down now. Well, thank you all very much for joining. Please do check out the Sprint website and sign up for the next one that Sean's going to be running, which will be the end of the week. Thanks ever so much, everybody. Thanks, Sean.
Thank you very much. My pleasure.